lovely work, 3D printing fashion, starting from your house, adopting new technologies in the design process, how you scale up, how you take it into a business. Please welcome Dr. Juan-Carlos Dürsteler, please. Thank you. From INDO. Thank you very much. The stage is yours. Your clicker, please. Done it? We need the clicker. Yes. Please. Thank you.
Okay. Thank you.
Carlos.
Well, good afternoon, everybody. My presentation maybe will not be so fancy. It is related to eyewear, like this that I have here. This is made by titanium and polyamide and made to my measure. You see that there are no spots here. So I would like to explain our project related to 3D printed eyewear. But first, let me explain. I'm the Chief Innovation Officer of INDO Horizons. INDO Horizons is kind of a spin-off of INDO. INDO is a Spanish company that has more than 75 years making frames, lenses, and equipment for the optician. And during the last years, we have been experimenting with the idea of having a completely personalized and customized spectacles. Just to introduce the thing, nowadays spectacles are designed in 2D with a sketch in paper. They make a prototype, typically by hand, and then this prototype is sent to China, and in China they make thousands of copies. The obsolescence of eyewear is about 15%. This means that from 100 spectacles that you make, you will throw out or sold under their price 15. And this is because when you make a collection, you make, for example, 20 or 40 different designs. You send them to China. They take 2 or 3 months to make the 15,000 that you order. And then in that time, you are selling that to your customers. And maybe you sell 15,000, or you sell 30,000, or you sell 5,000. If you sell 5,000, you have 10,000 that you will never use. If you sell 50,000, you will have a lot of them that you will not be able to sell because you are in the next collection season. So the idea is to make everything with 3D printing just in time. So the idea of the project Made for You is personalized eyewear. In this project, we developed a scanner, a 3D scanner of the face that is very quick. It takes 4 photographs in under some milliseconds. And with this information, you build the reconstruction of the face. With this reconstruction, we can make measurements on them, and we can make the spectacle to your measure. So you need also a virtual try-on in order to see yourself with the spectacle, since the spectacle is non-existent, and you have to see how will you look like with it. So we have developed a virtual try-on, an interactive one. And also, we have to develop some algorithms to change the shape of the spectacle without modifying the design. Making designs of spectacles are not so easy, and if you stretch and play with that freely, you can end up with something that has no sense or that cannot be manufactured. Then you have to place that on top of the nose, because you will wear some lenses, and if you need graduated lenses, if you need prescription lenses, you have to place them properly in the eye. So the scanner is also taking the 2 pupil positions that end up in this contact algorithm, in which what we do is we place the virtual frame into the virtual face, and then we compute the position of the eyes and all the optometric data that is needed to prescription lenses. Then we make with 3D printing, actually with an industrial 3D printer using selective laser sintering with high accuracy. And then we were also dealing with inkjet printing of decoration and automatic coloring of the lenses. So the end result is a set of frames. These frames are all of them of the same model. The differences are that you can see the bridge is different. You have people with big nose. The white one has a more narrow nose. So we can accommodate all this. We accommodate the length of the temples, the pantoscopic angle, all the parameters that are relevant in a spectacle. Well, this is a view of the scanner. We have right now a new one that I cannot show you, but in the end, it's a much simpler system, very performant. So what are the key enabling technologies on this? Basically, we are using CD reconstruction. This is my head, seen from the CD reconstruction in different angles. We use also in the virtual try-on photorealistic picturing. We can see the frame rotating and in any position so that the end user is able to see what frame is he or she selecting, and also the person can change the colors of each of the three pieces and obtain also the colors of the lenses, the properties of the lenses. And we provide a complete solution that includes the frame and the lenses. Nowadays, frames and lenses are made by different companies and the opticians just blend them. But with this technology, we can make the frame that actually blends perfectly with the lens and positions that in the perfect position for the optimal vision. So this is some of the frames of our last collection. And you see here, maybe better than in the previous slides, the difference between, this is the same model, but you can see differences basically in the boxing, in the bridge, the length of the temples, and well, pantoscopic angle is not easy to see here, but is also taken into account. So what are the barriers for this technology to reach the market? Basically, the look and feel that spreads into two things. The materials. Nowadays, we are playing with polyamide and titanium, cobalt chrome, materials that are biocompatible, that don't make any allergenic reaction. And an important thing about the look and feel of the materials is that nowadays we are competing with acetate frames that have transparencies, that have many inclusions, different colors, etc. So one of the biggest needs right now is to obtain multi-material printers that are able to produce frames with the mechanical properties appropriate and with the aging properties. So this is one thing, and the other thing is the surface finish. Typically what we do is polishing this with a tumble machine, but making textures is quite easy, but still some finishings are under research. So the finishing, the end decoration is another issue. For example, here you see these frames in acetate with many colors, with many inclusions, and typically polyamide is only one color dyed and this appearance. So the other barrier is price. Price is going down. Price is becoming more and more affordable. but still is a barrier, especially for metal. Titanium is very expensive if you use selective laser sintering, and polyamide is quite cheaper, but still is not in the range of what you can do with traditional technologies. If we look at what will be the future of these barriers, you can see that now Stratasys has just launched this multi-material system. This multi-material system is you see that it is possible to make very nice things, but the problem is that the materials age very badly. They become fragile and brittle, and they don't stand the time. So you can make prototypes with that, but you cannot do final products. The other promise is HP multi-jet fusion that you can see here in the fair, that has the promise of multi-materials, etc. And finally, the price will go down quickly in the future. So it is expected that 1 cubic centimeter will go down to $1.10 in a few years, and the speed will ramp up very quickly. So this is basically what I wanted to explain to you. We are now engaged in a commercial testing in one shop in Madrid to see how it behaves in the market. But we think that clearly, as you can imagine, this is the future of spectacles and of many things. Thank you very much.